This is the Tesla Power Podcast. This is where we're building the Tesla energy community. We're covering solar panels, solar roof, and Powerwall for your home. I'm Aaron Brady, and today let's talk about energy monitoring in the Tesla app. Let's ask the question, should you get a battery or shouldn't you? And let's talk about batteries and the Inflation Reduction Act and a lot more. Let's do it. So like we always do, we're going to start with community input, but don't forget that you can participate too. You can leave a comment below. You can link your YouTube videos. You can call 203-816-5150 to leave a message that I can feature here, or you can email teslapowerpodcast@gmail.com. And first up, we've got Brian Pendleton. He's got an update on his project that started way back at the end of February. Quote, breaking news. The local tech, Tesla retained one tech to continue to service installs already made in Western Pennsylvania, actually did fix the energy tracking issue, end quote. Now, to catch everybody up, Brian had a couple of hiccups in the process, driven by Tesla withdrawing their installation team from the area. They started construction on February 28th, and they were done March 4th. He passed inspection about 15 days later on March 19th. Everything going pretty smoothly up to that point, but then he hit his snag. The interconnect agreements in his area were delayed up to like 90 days. I mean, that's 3 months, right? Now, it didn't make sense to him because his utility and his municipality were confirming that they were waiting on Tesla. It wasn't the other way around. Now, ultimately, he found out that Tesla was withdrawing from his area, and he suspects that that was the reason for the delay. But ultimately, he did get PTO. That was July 25th, so about 150 days later. After work began anyway, but he was left with one final snag. The energy meter that Tesla uses couldn't get installed. There wasn't enough room in the breaker panel cabinet, so he was stuck with just the production data from his system and was missing the usage data to compare that with. Now, let's take a look at the Tesla app to get an idea of what this all means. I mean, it's hard to get your head around why the usage data is so important until you see how it's graphed in the Tesla app and how it gives you information about your system and how it's performing. So let me pull up the Tesla app and make sure it's on screen. Right here, you could see the summary screen. It shows the energy flow animation and some instantaneous values. You see there's no energy coming from the solar roof, and I'm pulling nothing from the battery, and about 1.5 kilowatts from the grid to supply the home. Now, below this animation, I get a summary of today's electricity generation. And then after that, I get a high-level impact report on how my generation compares with my usage. Now, we've just rolled over midnight. Well, it's about 2 in the morning now, but so it's showing 0% for today, but I should be able to look at previous days. Oh, this is giving me a whole 1 year summary. So I can break this down by day. Going back to yesterday. So yesterday I had 31% of my energy usage covered by generation from my solar roof. Now below that are the settings. And below that is the party trick to go off grid. And then the very last thing is the support link where I can request support. Now let's drill into the energy statistics, the very top link. This is where it will filter and graph the data at different time segments. Right now we have it filtered by day. Earlier you saw that my data was filtered by year, and you can do that, of course. But for this exercise, we'll look at the day. And you'll see here at the top, I can filter my graph by different usages. So if we go to yesterday, just to get a better baseline, you can see this first link is for home usage. The second one is for generation from the solar roof. The third is for battery discharge. And then this last one is grid usage. Now I can swipe between days, get a great one-look summary of all of these details graphed on top of each other. But just imagine if 3 of these 4 filters were blank. It just would make this app mostly not useful, right? And for me personally, it was these usage statistics that helped me figure out what the greatest energy hogs were in my house. You'll see in all of these daily graphs as I scroll through that I have a pretty consistent base energy usage. Now the scale changes over time, but for these, I'm using about 2.5 kilowatts pretty consistently. That's phantom load from my appliances and the pool pump. That's the biggest thing. And you'll see I have several spikes throughout the day. So this one's a really good example. There's 1, 2, 3, 4, 5 spikes. That's the AC compressor. So when the AC turns on, you'll see those spikes. And then there are different places where it's elevated throughout the day. Like just after 6 p.m., you can see that's when I turn on the oven or the stove. But the real jolt comes when my wife gets home and plugs in the car. It's like a huge shelf of energy freaking slapping the face of my wallet, right? Now, it's way cheaper than gas. I'm not complaining. But all of that detail was unavailable for Brian for the first weeks after PTO, which is a huge drag. So back to Brian's breaking news, Tesla was able to get the energy tracking to work, so he now has been made whole. He still has one big question. Should he get a battery or not? Now, if you've been watching for any length of time, you know my answer. I suggest you get at least 2 batteries for a whole home backup. But for Brian, no battery for now. 2 reasons. He's got net metering and he can just use use the grid as a battery. And that's nice while it lasts. Enjoy that, Brian. And then the second thing is he's not had any grid down events. So without any grid down events so far, spending money on a battery just isn't compelling for him. And totally get that. And here's to hoping that the grid maintains stability through the renewables transition, Brian. Keep us posted. Next, we've got Michael. He's made just a quick comment on the last podcast. He says, quote, interesting, a lot of practical detail, end quote. And I want to thank you for that comment, Michael. It's really helpful when viewers vouch for the content of these episodes so that new viewers know that it's worth their time. Thank you. Appreciate it. Next, we've got a comment from James Korines. He's got a great question about net metering and backup batteries. Let's read it. Quote, what percentage of reserve energy should I keep my Powerwall at if I have net metering? What is best for the batteries, 100%, 30%, etc.? And what percentage of cycling is bad for the batteries, end quote. Now, there are a couple of things here. So, number one, if you have net metering, just straight up, I recommend using the grid as your battery most of the time. Second thing, you can't limit the state of charge, but you can limit the reserve in self-powered mode. So let's go back to the app. I'll show you what I'm talking about here. The car that we've got, we keep it between 80 and 20. And that keeps its deep cycles out of factoring into battery degradation. But that isn't the main issue. So let me pull up the phone again. Back to the main thing. Let's go into settings, into Powerwall settings. And you can see our settings for controlling charge and discharge are here. I don't get to participate in a virtual power plant, so my only 2 operational mode options are self-powered and time-based control. You'll see I have self-powered checked because I have a flat rate from my utility. If I had higher rates during the day, I'd use time-based mode so that I could take advantage of using my battery when the grid was expensive and then go back to the grid when the grid was cheap. You'll see below this option, I even have the option of charging my battery on the grid when it's cheap if I need to. Again, I have flat rates, so I'm not going to do any of that. But that would mean I wouldn't even need solar to make a battery worth it if my grid had very high peak rates. Now, since I'm in self-powered mode, I want to use the grid as my battery, so I'm going to set the reserve to 100%. That means I never use my battery unless the grid goes down. Now, for me, this does 2 things. It lowers the number of cycles on the battery, potentially extending the useful life of the battery. In fact, pretty significantly if research bears out. And number 2, it maximizes the value I get from my net metering deal from the utility. Now, let's talk about this, right? Now, useful life, if we talk about that first, James raises a really valid concern. How long can the chemistry hold up at max charge? Now, Jeff Dahn, battery scientist at Dalhousie University, had published research showing that the greatest limiter of battery life was thermal management. State of charge was not a significant factor in cell longevity. Now, there have been concerns that batteries have a memory like older chemistries, but lithium ion doesn't suffer from this, so you don't have to worry about that. There is the matter of dendrites forming between the anode and the separator, which degrade battery life, but this is about speed of charge and temperature control. So again, thermal management. I've got a link to the video with Jeff Dahn's talk in the show notes if you want to take a look. But there have been a lot of chemistry and design improvements since that talk that go beyond these things. So I would assert that this is essentially a solved problem. I've got to admit, we don't know for sure yet because we're early adopters. We're going to be at the frontier of this knowledge. I can see, though, how it would be helpful to test this, specifically on my own system, right? So I'll do some thinking about a methodology I can repeat to track this over time. If you have input on this, hit me up in the comments. It'd be really interesting to get into that, I think. All right, next, Mark responds to my question about going solar panels rather than solar roof. Quote, I'm writing back on your questions from episode 60. I most likely would have considered Tesla solar roof if they had a terracotta option, end quote. And I mean, terracotta option was shown when the solar roof was first unveiled in 2016. We're all 6 years older, and there's still only one aesthetic available. That's the black rectangle textured panels. It's a bit of a shame, honestly. And there's no sign that any other aesthetic is even on its way to market. We had seen the brown textured glass in one of Gabe's flyover videos. You can see that house is going to be coming into view here. This is one of his factory flyovers in Fremont, California. They've just got the solar roof team in a corner of the factory parking lot where they can do some roofing training and, potentially some product testing. I don't know. I pointed it out at the time, but the color isn't awesome. I mean, I'd even go so far to say as it's a little bit ugly. You might remember that I first covered this way back in episode 3. And even then I said, it looks pretty low end. It looks a little bit better now that the angle has changed, so it's not so shiny. It doesn't have like that cheap plastic look, I guess. But it's just not a high-end aesthetic. If they were going for something, terracotta or slate, it could look very high-end and could probably, fetch them quite a bit of a premium. But I accept that getting the solar roof to this point has really been a challenge. Getting slate and terracotta aesthetics right would be another set of challenges. So, I don't know. It just would be great to see some movement on this front. And I would like to see more people looking for, a wider range of aesthetics able to adopt the solar roof. That would be kind of amazing. Anyway, thank you, Brian, Michael, James, Mark, all of you for your input. Let's hear from the rest of you, too. You can send in your YouTube links. You can comment below. You can call 203-816-5150, or you can email teslapowerpodcast@gmail.com. So let's take a quick break. When we come back, we'll get into the news. On this episode, we have the sister topic to last week's virtual power plant, and that subject is battery production. It's key to making this transition to renewables work at scale. It was, just like last time, this episode is sponsored by the fine new energy reporting of Electrek. First up, we have a story from Electrek noting that Tesla is finally not self-constrained for the car business anyway. Let's read what it's got to say. Quote, when following Musk's link, you end up having to order both Powerwall and Tesla solar panels. But in a follow-up tweet, Musk said that Tesla might open up orders for Powerwall by itself by the end of the year. For now, supply is too low, but ordering a Powerwall by itself should be possible end of year. This would signal that Tesla might be expecting to increase production capacity and be able to improve the availability of the Powerwall End quote. And this sentiment's been echoed by other Tesla officials over the last couple of weeks. And this is huge. If we're finally catching up on cell supply, we can expect to start to see battery storage roll out much more quickly. One concern I've had about the Inflation Reduction Act is that stimulating demand when there's not enough supply will, in fact, cause inflation. But production is starting to catch up in some areas, and the future is looking pretty bright. Next, we get some numbers on the batteries coming out of Gigafactory, Nevada. Some detail. Let's read that. Quote, the new leadership also stated that the factory needs to maintain a steady output of 8,800 high-voltage battery packs per week just to feed Fremont factory with packs for vehicle production. Tesla also managed to significantly ramp up Megapack production at the factory. The automaker is reporting a capacity to produce 42 giant Megapack per week compared to 34 during the last quarter. And the company also confirmed that it produced 37,600 Powerwalls in the second quarter, but it's now capable of producing over 6,500 Powerwalls per week, which should put Tesla's quarterly output at over 70,000 Powerwalls, end quote. And of course, it's the stationary storage for residential that we care the most about. And $70,000 or 70,000 Powerwalls per week or per quarter, sounds like a lot. I mean, that sounds awesome, actually. If this were for domestic customers only, that would be even better. But I have a feeling these are still going to be shipped to international markets. Now, I'm not downplaying this that much. This is still a lot of battery capacity coming out of a single factory. And I don't know, let's see how that improves over the next few years. And there's more. But wait, there's more. It may be the only Powerwall factory at the moment, but Tesla is ramping another factory in California. Quote, last year, Tesla broke ground on a new Megafactory, to produce Megapack batteries in Lathrop, California. The goal is to have a new factory focused only on building the large battery pack for utility-scale energy storage projects. CEO Elon Musk revealed that Tesla aims for Megafactory to produce an impressive 40 gigawatt hours of Megapacks per year. Tesla has been working on the new plant for a year now, and it's starting a significant hiring effort to staff the factory, end quote. So on top of the Nevada Gigafactory, we have the California Megafactory that's dedicated to serving grid-scale storage solutions. Now, you might wonder how it's able to scale these facilities, and I'll bet it's because they're switching over to iron chemistries. We've been expecting Tesla to move to iron for stationary storage to remove the nickel bottleneck, and this level of increase would indicate that they have now done it. But what about the other major component, lithium? Well, we have this story of a new contributor in North America. Quote, although it has only explored 1% of its 55,000 acre site in Canada, carbon-conscious mining company Snow Lake Lithium believes it can enable a massive domestic supply of the chemical element to EV automakers when it begins commercial mining. The company expects its all-electric mine to source enough lithium to power up to 500,000 EVs in North America each year, which could prove vital in the U.S. as the automotive industry shifts its supply chains domestically in order to qualify for revised federal tax credits, end quote. And they call out the automotive industry, but that doesn't mean it's going to be the final destination of this mineral. If Tesla needs loads of lithium to produce its batteries for stationary storage, it's going to be a prime supplier, if only because of its location. I expect the Defense Production Act will shake loose a few lithium mines in the United States as well. But what is Tesla going to do with all that unrefined lithium? Well, let's read the next story. They are going to refine it, of course. They say, quote, in an application filed with the Texas Comptroller's Office and obtained by Reuters, where Tesla is seeking to obtain relief on local property taxes, the automaker describes a battery-grade lithium hydroxide refining facility to be built on the Gulf Coast of Texas. The potential battery-grade lithium hydroxide refining facility, which Tesla touted as the first of its kind in North America, will process raw ore material into a usable state for battery production, the company said in an application filed with the Texas Comptroller's Office, End quote. Now, they are absolutely not messing around here. They plan to grow automotive very aggressively over the next 8 years. But Elon Musk has noted that the energy business should be about the same size as the automotive business. And Zach Kirkhorn has mentioned that the energy business is going to have to grow at a higher rate than the automotive business to catch up. And I mean, this is just a small view of how all of this is going to get done. These are exciting times for sure. We're watching the pieces come together in real time to make a renewable energy economy possible. Not saying this is a done deal. Make no mistake. There are problems to solve after this break. We'll get into a couple of those problems in our future video that asks some important questions. The YouTube gods have served me up some Sabine Hossenfelder recently. She is a YouTube science communicator. She seems to be German. She's got that dry German sense of humor laced throughout her breakdown of challenges of a new energy grid. Now, she is introducing the German compound noun Dunkelflaute, which translates into dark lull, and it's the affliction endured when there's no wind and no sun. Obviously bad things for renewables, right? Now, she's also obviously working on coining a new Schadenfreude, and she sees two routes to resolution. Here's a clip.
Okay, so how can we deal with the Dunkelflaute problem? There are basically two options. One is better connectivity of the power grid so that the risk can be shared between several countries. However, this can be difficult because neighboring countries often have similar weather conditions. A recent study by Dutch researchers found that even connecting much of Europe wouldn't eliminate the risk. And in any case, this leaves open the question whether countries who don't have a problem at the time could possibly cover the demand for everyone else. I mean, the energy still has to come from somewhere. And then there's the problem that multinational cooperation doesn't always work as you want. Instead of being dependent on gas from Russia, we might just end up being dependent on solar power from Egypt. The other way to address the problem is storing the energy until we need it. First, some technical terms. The capacity of energy storage is measured in watt-hours. It's the power that the battery can supply multiplied by the discharge time until it's empty. For example, a battery system with an energy capacity of 20 gigawatt-hours can power 5 gigawatt for 4 hours before it's empty. This number alone doesn't tell you how long you can store energy until it starts leaking. This is something else to keep in mind. At the moment, the vast majority of energy storage is pumped hydro, which means you use the energy you don't need to pump water up somewhere, and when you need the energy, you let the water run back down and drive a turbine with it. Currently, more than 90% of energy storage is pumped hydro. Problem is, there are only so many rivers in the world, and to pump water up a hill, you need a hill, which is more than some countries have. Much of the increase in storage capacity in the past years comes from lithium-ion batteries. However, they still only make a small contribution to the total. To give you a sense of the problem, at present we have 34 gigawatt-hours of energy storage capacity worldwide, not including pumped hydro. If you include pumped hydro, it's 2.2 terawatt-hours. We need to reach at least 1 petawatt-hours. That's about 500 times as much as the total we currently have. It's an immense challenge.
And I've linked the video in the description. Of course, you can see what energy storage options she highlights in addition to lithium-ion battery, but we can see the size of the challenge here. Even if Tesla were to hit its goal of 3 terawatt-hours per year of battery capacity in 2030, and all of that went to stationary storage, we would need more than 30 years to reach the estimated 1 petawatt-hour of storage required. And our energy requirements will likely go up in the next 30 years, so this is going to be a moving target. So the scale is really hard to grasp. And I don't know, it might even mean there isn't a path to 100% renewable grids for the foreseeable future. Not to say it's not a worthy pursuit. It is a worthy pursuit. And if we're all moving to meet our own self-interest by working toward essentially free energy, or less ambitiously, toward individual energy independence, then we have a fighting chance of reaching this goal worldwide someday. If we had 30 more Teslas, we could do it in a decade, you know? And I mean, there are others that are working on this. I realize that. I don't mean to imply that Tesla's going at this alone. It just would be nice to see more ambition from more market players at this stage of the game. Now, from my experience, no progress on PTO. My last follow-up email received an automated response from the Tesla account. They are noting that inquiries would be forwarded to the project advisor. I don't even know who my project advisor is at this point. I'll keep on it. Not a lot to say about that, right? But that will do it for the Tesla Power Podcast, episode 64. Please use my referral code. You can save $300 on a solar roof, $300 on solar panels. You can go to ts.la/Aaron62310 to place your order. And I'm Aaron Brady, your Tesla Residential Energy Community Organizer. Let's do this again on the next video.